What is statistics? Statistics is the science of collecting and analyzing numerical data in large quantities, inferring population from samples. It is a branch of mathematics that transforms data into useful information for decision makers. There are two main branches of statistics. Descriptive statistics helps summarize and present data, and inferential statistics use sample data to infer the population. Let's look at several basic definitions. A variable is basically a characteristic of an item or individual. For example, color, salary, price, etc. Data is a set of individual values associated with one or more variables. And usually when we work with a dataset, we have a number of variables and many observations. Statistic is a value that summarizes data of a particular variable. Let's see how we can classify variables by types. Categorical or also qualitative variables. Take categories as values. An example is the responses for the question if you are greater than or equal to 18 years old. The values can be yes or no. Another variable is the car colors, maybe blue, brown, or green, or even more. Another type of variables is numerical or quantitative variables that have values representing a counted or measured quantity. Discrete variables arise from a counting process, while continuous variables arise from a measuring process. So let's say if there is a question, do you have a Facebook profile? The responses may be yes or no. This variable type is categorical. Another question is how many text messages have you sent in the past 3 days? This variable type is numerical and discrete. And another question is how long did the mobile app update take to download? The variable type now is numerical but continuous. Categorical variables can be nominal and ordinal. Examples or example for nominal variables include marital status, maybe divorced, maybe single, maybe married. Another example is political party, which can be Democratic or Republican, and also eye color, maybe blue, maybe black. And here we can see there is no ordering between categorical values. Now talking about ordinal variables. There is some ordering between ordinal variables. So looking at some examples, we may have values such as good, better, and best, and also low, medium, or high in ratings. Numerical variables can be discrete or continuous. Examples for discrete variables include the number of children, the defects per hour, and finally, examples for continuous variables include width and voltage. Now talking about levels of measurement. A nominal scale classifies data into distinct categories. No ranking is implied. A variable, for example, personal computer ownership, Its values may be yes or no, and there is no ranking between yes or no. Other examples include the type of stocks owned and internet provider. The next scale is the ordinal scale, which classifies data into distinct categories and in which ranking is implied. The first example is student class designation. We may have freshman, sophomore, junior, and senior. Looking at these values, we can see there's some ranking implied. Other examples include product satisfaction, faculty rank, S&P's bond rating, and student grades. Next, we talk about an interval scale, which is an order scale. The difference between measurements is a meaningful quantity, but the measurements do not have a true 0 point. A ratio scale is an order scale in which the difference between the measurements is a meaningful quantity, and the measurements have a true 0 point. Let's look at a few examples. The first example is temperature, can be in Celsius or Fahrenheit degrees. On the two scales, the difference between the two temperatures, either in Celsius or in Fahrenheit degrees, is actually the same. So having something called interval of temperature makes sense. However, temperatures doesn't have a 0 point, and here we mean true 0 point. A true 0 point for temperature would mean no temperature at all. Let's also take another example, and this an example for ratio scale. So height can be in inches or centimeters. If you measure the differences of two different heights in inches and then also in centimeters, the differences are the same. Also, if you measure the ratio between two heights in inches and then also in centimeters, the ratios are the same. So here, ratio scale has a true 0 point, and it makes sense. Other similar examples include weight, age, and salary. Now, talking about population and sample. A population consists of the items, all items, or individuals that you want to draw the conclusion. The population is also called the large group. A population parameter summarizes the value of a specific variable for a population. A sample is the portion of a population selected for analysis. The sample is called the small group. And a sample statistic summarizes the value of a specific variable for sample data. Now we talk about sampling. The sampling frame is a list of items that makes up the population. Frames actually are data sources such as population lists, directories, or maps. Excluding some certain portions of the population in a frame may result in inaccurate or biased result. We should note that using different frames to generate data may lead to dissimilar conclusions. This chart shows the types of samples. There are non-probability and probability samples. Non-probability samples can be judgment or convenience samples. Probability samples can be simple random, can be systematic, can be stratified, and it can be cluster samples. In a non-probability sample, items included are chosen without regard to their probability of occurrence. In convenience sampling, items are selected based only on the fact that they are easy, inexpensive, or convenient to sample. In a judgment sample, what you get is the opinions of pre-selected experts in the subject matter. In a probability sample, items in the sample are chosen on the basis of known probabilities